Hello. In my previous video, we discussed about Diffie element key exchange and how the algorithm works. Now, let us see one example about how a secret key is communicated between a sender and a receiver. Just we'll recall the algorithm. In the algorithm, we take the global public element Q is the prime number and we are taking alpha such that alpha is the primitive root of Q. I also uploaded a video to check whether how the number is a primitive root of a prime number. And then there are two users, user A and B. We're having A and B. What is happening in the both the side? Each user will select a private key. Here A taking XA, B taking XB. They are private to itself. Then using the alpha, they calculate YA. This is the public key. Similarly, B calculates YB. This is their public key. So in the second step and third step, user A and user B generates their public key. Then they will swap, they will exchange the public key with each other. So A is aware of B's public key and B is aware of A's public key. And in either side, they calculate the secret key K by using this expression. So let us see one example. So the first step, global public elements. Let us take here, we are taking Q equal to 7. Q equal to 7 and alpha equal to 3. It is already proven in the previous video that 3 is the primitive root of 7, so need not bother about the same. And the parameters they are given are the private key of XA we are taking as 2 and private key of B, that is XB, is given as 5. So these are the parameters what we are having in our hand. Let us do a calculation. This is the first step is over with the global parameters. Second step, user A generation. So here we are taking XA as 2 and we already know that we are having Q equal to 7 and alpha equal to 3. Now calculation of A's public key YA is given by alpha power XA mod Q. The alpha is 3, so 3 power XA is 3 power 2 mod 7. 3 power 2 is 9, 9 mod 7 which is equal to 2. So here I have YA equal to 2. This is A's public key. On the other hand, what is happening in the B side, other recipient or other party? Here we are taken XB equal to 5. Then again the same method to calculate the public key YB equals alpha power XB mod Q. Here alpha is 3, x power 5 is 5, 3 power 5 mod 7. So 3 power 5 mod 7 gives 5. So here we are having YB equal to 5. Now both the party A and B has calculated their private key and public key. Now they both exchange their public keys to know each other. So YA is given to known to B and ODB is known to A. Now by this they are calculating the secret key K equals YB power XA mod Q. Here YB is 5, XA is 2. So 5 power 2, Q is 7, 5 power 2 mod 7. 5 power 2 is 25, 25 mod 7 which is equal to 4. So K equal to 4 in A side. Similarly, from B side, calculation of secret key is K equals YA power XB mod Q. I'm following this K equal to YA is 2 and XB is 5 mod 7. 2 power 5, 32, 32 mod 7, 4. So when you look at this, they both are calculating independently, but they get the same secret key K. So this is how the Diffie-Hellman algorithm is used to exchange the secret key or to share a secret key among two different parties based on exponentiation or Gaussian field model of prime. Thank you.